Hey guys, sorry I couldn't be there with you today. As many of you know, I'm in graduate school working on getting my master's degree, and I'm kind of in the middle of working on this last big final project I have to do. And so I just needed some extra time to stay at home and work on that. So I'm basically at home doing my homework right now. Um, so as you know from the last time we did this, the expectation is that you're learning and doing just as much on the days that I'm not there with you as the days that I am there with you. So everything that you do in class today should get turned in at the end. You should be following along and getting stuff done just as if I were there. So you should have picked up this warm up as you walked in the door. Um, they're all questions asking you to find a part. They're giving you a percent and they're giving you a whole, and you got to find a part. And so um, you could always keep this formula in mind. The part equals the percent times the whole. And what this essentially says is y equals k times x. It's the same stuff we've been doing. So I'm going to just do a couple as examples for you. A lot of these, many of you could probably do in your head. If you can, that's great. Do them in your head. If you can't do them in your head, especially some of the later ones on the right side, the right column here, what you do is just grab your calculator. This one's kind of jacked up a little bit. Stop jacking up my calculators, everybody. So convert the percent that you're given to a decimal. I'm just going to pick a random one here. I don't know. Let's do 75%. So I'm going to convert that to 0.75. And I want 75% of 22. So I'm just going to multiply by 22. And I'm going to get 16.5. So 75% of 22 is 16.5. And you can just use that strategy for all of them. It's just convert the decimal. I'll do a couple more. I'm going to convert this decimal 0.80. And I'm going to multiply that by 22. And I get 17.6. Let me do a couple from the left-hand side as well. Let's see here. We got, so a lot of these are easier because they're 10%. But even with those, if you wanted to use a calculator, you could go 0.10 times, let's see here, let's do 200 times 200 equals 20. So that one's going to be 20. All right, so for all of these, just convert the percent to a decimal and then multiply by the number they give you. We don't usually do these with a timer, but for the sake of the fact that I'm trying to make this video timed properly, I think I'll give you 4 minutes to do this. If you finish in that time, great. If you don't, that's okay. Just fill it in and follow along with me when I give you the answers at the end of the 4 minutes, all right? Oh, why did I do all that? There we go. Okay, you're gonna be done in 5 seconds. 4, 3, 2, 1. I think I somehow managed to silence my timer. It's not making beeps now. Okay, whatever. So stop working. If you didn't finish in that time, that's okay. If you did, great job. If you got all those done in 4 minutes, it's pretty good. So here's my answers. I just did them in that same 4 minutes you guys had. So I might have messed up somewhere in there trying to go that fast. If you see a mistake in there, call it out. But if you're just using the calculator the whole way, you should have been okay. So a couple of things that maybe you could notice. Notice how here, when you had 10% of 35, it's 3.5, and then 10% of 36 is 3.6. Well, the number that you're taking a percent of increased by 1, and 10% of 1 is just 0.1. So your answer increased by 0.1. I thought that was kind of interesting. Here, you got all these 22s. And so you could kind of, like the idea is that you're kind of seeing a pattern as you go, like the 10% is 2.2. So you could double that to get 20%. And you could triple 2.2 to get 30%. And then here, when you're asked to do 25%, you could think, okay, well, 10% is 2.2, 5% is half of that. So that would be 1.1, which you need down here. So 25% should be whatever 20% was, plus whatever I could figure out 5% was. Like if you're trying to do this whole thing in your head. If you didn't do it in your head and you're just punching numbers in the calculator the whole time, that's fine too. But it's fun to talk about like these strategies of breaking things down into pieces in your head and trying to come up with it that way. Let me make sure I'm showing everything. So here's the bottom answers. It's hard to fit everything on the screen in this current setup. Here's the top answers again, in case anybody needed to see those again. All right, hang on to that paper because you're gonna need it to write some stuff on the backside later, because we're gonna work in this packet right here. This is the one that we were doing. This is the backside. You'll recognize it better if I show you this side. So get this packet out. Lesson 3, comparing quantities with percent. This is the one we did the first page front and back on Wednesday or Thursday, depending on which day you had this class. And we're gonna finish the other page front and back today. So please get this out. I'll wait a minute for people to get it out. If you lost your copy or can't find it for whatever reason, I made a few extra copies and they're on the front counter right near where my cart is that has the document camera, like where I keep extra pencils for students. There's a stack of a few extras of these. You can grab one if you need it. But I didn't make too many copies, so please find yours rather than just grabbing one of those copies. You will be asked to turn this in at the end of the period for a completion grade to show me that you're following along and doing what you're doing, even though I wasn't there today. So make sure your name's on it. While you're waiting for other people to find theirs and get ready and all that stuff, write your name on this because you're gonna have to turn it in at the end of the class period. You're also gonna turn this in because we're gonna do some work on the back side of it. We're gonna use the back side of this paper. So write your name on this paper too, so that I don't get any no-name stuff when I'm looking at what you guys did while I was gone. All right. So I'm gonna say it again. Write your name on this one. Write your name on this one. Okay. Hopefully that was enough time for you to find your paper. I want you to flip to the second page. And I want you to try these 2 questions here. You can work with your neighbors or work by yourself, whatever you feel like today. But let me preface something first. We've talked in class about this thing called the of trick. The of trick is a way to identify the whole value in the question. And the way I've phrased it is look for the last usage of the word of in the question, and then whatever follows that is usually your whole. Well, the problem is sometimes the word of is in the names of the quantities in the question. So if you look at number two, it says number of students in the band. That's not the usage of the word of you would want to look for in this case, even though it's the last usage of the word of in the question. So let's read the whole thing and then let's see where if we can figure out what the subtle difference is in this one. It says at Kent Middle School, there are 104 students in the band and 80 students in the choir. What percent of the number of students in the choir is the number of students in the band? So if you look at the three usages of the word of here, 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 and here, where it says number of students in the choir, that of is like part of the name of the quantity, right? It's the number of students. So that of isn't really like a part of the sentence trying to tell you something. And same thing here, number of students in the band. It's like, that's the name of the quantity you're talking about, the number of students. The last time that they use the word of in relation to the percent, like setting you up in the question, is here. What percent of the number of students in the choir is the number of students in the band? And so, another way you can use the word of to help you is that the of that you really care about, the one that's prompting you that the next thing is the whole, usually follows the word percent. What percent of the next thing? We want a percent of the next thing. So this is the of that you care about. This is the of that's telling you the next thing you read is your whole value. Okay, so I want you to keep that in mind for this question and this question. Do both of these. Identify the part, percent, and whole. Show your work. Show the calculation. Like if you punch something in the calculator, you still got to write out what you calculated, and then write a word conclusion to both of these questions. It's only 2 questions though, so I don't know. How about 6 minutes to try these? It should be good. Go for it. All right, we're gonna come back in a little less than 10 seconds. 5, 4, 3, 2, 1. Beep, 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 beep. I gotta figure out what happened to my timer. All right, hopefully you guys are stopping, getting quiet, space in front in case you're turning around working with somebody. I'm gonna go over these two questions real quick. So as I read this question, at Kent Middle School, there are 104 students in the band, underline that, 80 students in the choir. What percent, so just the fact that right there, they're asking what percent, that tells me the percent is the unknown in this case. So I'm gonna label that over here. Percent equals the unknown. And so one of these numbers is my whole, one of these numbers is my part. If I go back to what I was saying earlier, what percent of the number of students in the choir, okay, so that tells me I'm taking a percent of the students in the choir. So that means the students in the choir must be my whole. So the whole is gonna be, let's see, students in the choir, 80, right there. So my whole is gonna be 80. By default, the other value in the question must be the part, but also it's asking me what percent of the number of students in the choir is the number of students in the band. So that's the thing that they want represented as a percent. And so the band is this 104 right here. Okay, and so like I've been saying, there's a couple ways you can think about this. You can think about it as like the whole is always like your X value, if we were thinking about proportional relationships. And the part is always like your Y value, if you were working in proportional relationships. And so it would be like if it were set up like this, 80 over in the X column, 104 in the Y column. And then I said, hey, find me a constant of proportionality. And you would probably draw a third column onto the table and you'd call it the Y divided by X column. And then you just do Y divided by X, right? So what do we got? 104 divided by 80 equals 1.3. Okay, so 1.3. But we need to convert that to a percent. So we move that decimal point over 2 spaces. We get 130%. If you prefer though, you can just remember the formula. Percent equals part divided by whole. Either way, you're still doing the same thing, right? You're still taking the part, the Y divided by the whole X to get the percent, which we think of as like our K. Whichever way works better for you. So we're supposed to write a little conclusion. Let's see here. The number, I'm going to be lazy and I'm going to short that to NUM for num, of students in the band is 120% that of the number of, I guess this word that wasn't really necessary, is 120% of the, yeah, I don't know. I think you can have it or you don't really need it. It's whatever. 120% of the number of students in the choir, right? Choir. Works for me. All right, let's go on to the next one. It says at Kent Middle School, breakfast cost $1.25 and lunch cost $3.75. What percent of the cost of lunch is the cost of breakfast? See, this is another one where like the quantity names have the word of in them. Cost of breakfast, cost of lunch. Those aren't the usages of the word of that we care about. We care about what percent of. So we find that of, and it kind of tells us that the thing immediately following that is going to be our whole. So first of all, I see that it's asking me what percent, right? So that means the percent is going to be the unknown. And right after what percent of, I see cost of lunch. So that tells me cost of lunch is going to be my whole, which is right here, $3.75. So in the previous question, the whole was the smaller number and the part was a bigger number. So we wound up with a percent greater than 100%. This time it looks like the whole is the larger number and the part is the smaller number, the breakfast 125. And so this time we should wind up with a percent smaller than 100. That's pretty much how it always works. If you're comparing a bigger number to a smaller number, you get a percentage over 100. If you're comparing a smaller number to a bigger number, then you get a percentage lower than 100. Simple as that. All right, so it's the same as before though, right? We're trying to find a percent. We got a whole and a part. So we're gonna wind up doing part divided by whole, or y divided by x, whichever way you like to think about it. So this time I'll write it like this. Percent equals, so I'm doing this right here, part divided by whole. So my part is 125, my whole is 375. And I can see that this is 3. This is a ratio of 3 between these two, right? 3 times $1.25 would be 375. So this is 1/3. And you're supposed to have this one memorized. If you're still working on it, please get this one in your brain. This is 33. Oops, I put a decimal point where it didn't need to be. 33.3 repeating percent. So we write a little conclusion that says breakfast costs 33.3 repeating percent of the cost of lunch. Boom, got it. All right, so the next one's a little weird, little tricky. It relies a little bit more on algebra than we've practiced this year. And so I'm sure there's some of you in this room that could do this one without the help and the prompting that I'm gonna give. But I think we're gonna talk about it and then I'll give you a little thing to work on it with it. So it says, describe a real world situation that could be modeled using the equation 398.4 equals 0.83 times x. So let's break this equation down. This equation is in the form of y, think of 398.4 as your y, equals k, think of 0.83 as your k, times x. We got an x. Or in other words, it's in the form of, I'm going to write it down over here. Part equals percent times whole. Right? I recognize this equation as being like this. 398.4 is the part. Then I've got an equal sign. 0.83 is the percent, 83%, right? And then our whole is unknown. We've got an x where our whole would normally go. And so this equation is modeling the type of question where you know your part, you know your percent, but you don't know the whole. So describe how the elements of the equation correspond with the real world quantities in your problem, then solve your problem. So I'm going to sort of like give you the problem based off this and then just ask you to solve it. So please copy this. Barry the bear, I don't know why, I think I was already getting ready to write the next word because the next word was traveled. Traveled to the bare planet. Geez, I can't write today. Planet birth. Birth has 83% the gravity of Earth. And so you should have learned in a science class at some point by now as 7th graders that gravity determines how much you weigh. Gravity determines how much you weigh. When you weigh yourself or weigh something, you're essentially measuring gravity's pull on it. And so different planets have different amounts of gravity based on how big they are. Big planets have a lot of gravity, little planets have less gravity. And so Earth must be slightly smaller than Earth if it only has 80%, 83% the gravity of Earth. And so that means anybody on Earth is only going to weigh 83% as much as they would on Earth. So Earth has 83% the gravity of Earth. If Barry weighs 398.4 pounds, and I will abbreviate pounds as LBS, on birth, How much does he weigh on Earth? Okay, so hopefully you can see how this word problem matches up with the equation we're given. We've got the fact that he weighs 384 pounds, and that equals 83% times his earth weight, which is X, the thing that we don't know. That's the unknown in this question. So your unknown is going to be your whole, which is his earth weight, but you know a part and a percent. See if you can remember how to figure out that kind of problem. I'm going to give you about 3 minutes to try this one. All right, we're coming back in a little less than 10 seconds. 5, 4, 3, 2, 1. All right, start getting ready to listen. Face the front if you turned around, all that good stuff. All right, so let's identify the parts first, or I guess I should say the pieces. So in this case, our part is the 398.4 because that's only a part of the earth weight that Barry has on birth. And then the percent, well, we were given that as well. It's the part represents 83% of the whole in this case. 83%. And the whole is the thing that we don't know in this case. And so there's a formula for this that you can memorize, but I'll write it at the end after I show you a proportional relationship way of thinking of this question. Since the part is like Y and the percent is like K and the whole is like X, you could think of this as like if you had a proportional relationship situation, and over here it said whole X, and over here it said part Y, and then maybe over here, I've already given you the constant of proportionality, so the K or the percent. And over here it said, I'm going to convert right now. Instead of writing 83%, I'm going to write 0.83. And the part says 398.4. And you were supposed to fill in this table. Well, when we work from X to Y going in that direction, you multiply by your K. But when we go from Y to X, working backwards in this direction, then you divide by your K. And so in order to fill this box, we would need to do 398.4. 398.4 divided by 0.83, which equals 480. So you could think of it that way. You could also just memorize the formula whole equals part divided by percent, which is exactly what we did, right? We did the part divided by the percent. But in either case, let's write a little conclusion. Barry the bear weighs 480 pounds on Earth. All right. So we're going to work on the back side of this page a little bit too, but there's not really that great of like space to show your work on this paper. And so what I'm going to ask that you do is you should have still saved this thing. You're going to work on the back side of it, show your work, like number whatever question you're working on or we're working on, and show your work. And then at the end of the period, when you turn all this stuff in, what you'll do is you'll take this one and you'll put it like inside this. So kind of might be kind of hard to see what I'm doing, but I opened up the 2-page packet. I'm going to slide the sprint with my work on the back in it, close it, and turn it in that way with the page inside. But we're not doing that yet. Based on what I got on the timer here, I think there's still about 10-ish minutes left in class. So let's get some work on the back side of this paper, and then it'll be worth turning in, right? So here we got solve each problem using an equation. You don't have to use an equation. I'm going to give you a couple minutes to just try these three here, 1A, 1B, 1C. Show your work on the back side of your sprint. So label them 1A, 1B, 1C. But I don't care if you use an equation. Just do the calculations with the calculator or use a table or whatever method you like. But I'm going to give you 2 minutes because these are relatively easy to get me answers for 1A, 1B, 1C on the back of your sprint sheet. Okay, we're coming back in about 10 seconds. 5, 4, 3, 2, 1. All right, start to get ready. You know what? I hate how much bleed through there is on this paper. I'm gonna go grab a fresh version of this packet so it's not all like that. All right, you should be ready to go by now. So all of these are ones where you're given a part and a whole. The number after the word of is your whole in each one of these. So that's a whole. This is a whole. And this is a whole. So notice that this third question is worded slightly differently so that the whole comes before the part, but it's still, you're taking a percent of 80. So that's your whole. And so the other number that I didn't underline in each one would be our part. And so you're given a part and a whole. You need to find a percent for all three of these. So I'm gonna come over here. All right, I'll do it like this. So for 1A, 1A, let's see here. I could make a little table. I'll show you like different ways of thinking of this. And so I've got my whole, which is X, and my part, which is Y. And so the whole in this case would be 33, and the part is 49.5. So our part is bigger than our whole in this case, so we should come out with a percent that's bigger than 100. And so the percent, or the K, is just going to be Y divided by X. I'll do that real quick. So I do 49.5 divided by 33 equals 1.5, which equals 150%. That's one way you could show your work. Another way you could show your work is just by maybe writing out the formula, showing me what you're doing. So the formula in this case is, it's just like finding K, Y divided by X, but instead it's percent equals part divided by whole. And so for 1B, let's see here, the whole is the 180, that goes on the bottom, and the part is 72. So this time we have a smaller part out of a bigger whole, so our percent should turn out less than 100. I'm going to guess about 40%. Let's see. 72 divided by 180 equals, hey, I called it. Oh, sorry, I was off the screen. But yeah, I did it. I got 0.4. So we show that we get 0.4 as our answer, and then we say that that's equal to 40%. I really appreciate it if you show me what you got on your calculator as a decimal, and then show me that you're making that conversion rather than just writing 40%. All right, and then on the last one, since we've already done a couple of these and we've shown our work in different ways, this last one, I'm literally just going to show the division. It's 80 is the whole, so 90 is the part. So I need to do part divided by whole. It's just going to be 90 divided by 80. That should be the same as 9 divided by 8, which is 9/8. 1.125. Let's see. 90 divided by 80. 1.125. And so I move that decimal point over 2 spaces, and as a percent, I get 112.5%. Okay, let's see here. How much time have we used so far? Where are we at on time? Okay, there should be maybe like 5-ish minutes left in the period. So what I'd like you to do is just work on as many of these questions on the rest of the page as you can about Benny and Jenny and Penny and his mom and their percent ages or whatever. Some of them can be kind of tricky, but I just want to see what you can do with them. So keep showing your work on the back side of this page, and work until the period is about to end, and then the substitute teacher that's with you today will collect this work from you. Remember, take the page that you're showing your work on the back side of and put it in to the 2 other pages and hand it in that way. All right, I'll see you tomorrow.